So guys, welcome to our channel once again. In today's video, we have here these 10 questions to answer on the topic structure of the nucleus. So in short, stay till the end of this video. Let's go ahead and start with the first question here. It says, two isotopes of uranium are designated as 238U and 235U. The numbers 238 and 235 represent their A. Proton numbers, B. Nucleon numbers, C. Atomic numbers, D. Neutron numbers. So guys, the answer to this question is option B. Nucleon numbers. So let's go ahead and consider the next question, guys. So the next question here is question number 2. It says, the half-life of a radioactive substance is A. The length of time needed by the substance to decay completely. B. The length of time during which the activity of the substance reduces by 50%. C. 1/2 the value of its decay constant. D. Its average lifetime. So guys, the answer to this question is option B. The length of time during which the activity of the substance reduces by 50%. And that's it for this question. Let's go ahead and consider the next question. So guys, the next question here, question number 3 here, it says, the mass of proton is 1.0074 mu and that of a neutron is 1.0089 mu. Determine the energy evolved in stabilizing the nucleus of nitrogen of a mass number 14 with 7 protons and 7 neutrons. So guys, for this here, we are going to recall that the energy will be half mv squared. So in order to get the mass, we'll get the mass of the proton here and as well the mass of the neutron here. So starting with the mass of the proton here, we said we have 1.0074 mu, and actually mu is stated here to be 1.67 times 10 to the power of negative 27. So since we have this stated here as mu, then the mass here for one proton will be 1.0074 times 1.67 times 10 to the power of negative 27. And then mass of one neutron will be 1.0089 times 1.67 times 10 to the power of negative 27. However, the nitrogen atom here has 7 protons and 7 neutrons, and as such, we're going to multiply each of these by 7. So we'll multiply this mass of proton by 7, and then we'll also multiply the mass of electron by 7. So guys, with this, we will have the mass of the proton to be 1.178 times 10 to the power of negative 26, and that of the neutrons to be 1.179 times 10 to the power of negative 26. So guys, if we add these two numbers together, we're going to have the mass of this nitrogen, and adding this together we have about 2.37 times 10 to the power of negative 26. So guys, if we have this mass here and then we'll now apply this equation here, half mv squared, we're going to have 1/2 times 2.37 times 10 to the power of negative 26 times the square of the velocity here. The velocity, which is the speed of light here, is 3.0 times 10 to the power of 8. So we'll square this, and then let's go ahead and calculate this all through. We are going to have 1.710 times 10 to the power of 8, which is option C here. So that's it for this question. Let's go ahead and consider the next question. So guys, the next question here is question number 4. It says, Which of the following are the essential parts of an atomic bomb? We have A. Uranium and alpha particles, B. Uranium and polonium, C. Nitrogen and neutrons, D. Uranium and neutrons. So guys, the answer to this question is option D here, uranium and neutrons. So that's it for this question. Let's go ahead and consider the next question. So the next question we have here is question number 5. It says a nuclide 202 and 84 gamma here emits in succession alpha particles and beta particles. The atomic number of the resulting nucleotide is. Alright, so guys, if this stuff emits alpha particle, actually alpha particle is the same as helium atom. So in that case, that will be 4 here and 2. So in that case, the mass here will reduce by 4. So that's 202 minus 4, and that will be 198 here. And then 84 minus 2 will be 82. So in that case, it also emits a beta particle, and beta particle actually has the mass of 0, and then the atomic number here will be -1. So in that case, the mass here will remain 198, and then the atomic number here, since it emits a beta particle, that will be minus a -1, which is +1, and that's 83 here. So 82 plus 1 is 83. So in that case, the atomic number of the resulting nuclide is 83, and that's option D. So let's go ahead and consider the next question, guys. So the next question we have here is question number 6. It says a muscle is represented by 70:32b. So determine its neutron-proton ratio. So guys, for this question here, we have to recall that the atomic number is the number of protons. So as such, 32 here, which is the atomic number of this, is the number of protons. So to get the number of neutrons, actually the number of protons plus the number of neutrons will give the atomic mass. So since the atomic mass is 70 here, that means 70 minus 32 will give us the number of neutrons, and that's 38. So the ratio of the neutrons to protons is 38:32. So that will be 38/32, and that's 1.2. So that's option D here. Let's go ahead and consider the next question, guys. Alright, so guys, the next question we have here is question number 7. It says an atom that emits an alpha particles A becomes a daughter of a different element always. B becomes a different isotope of the element. C becomes a daughter with increased mass. D may become a daughter of a different element. So guys, the answer to this question is option D. An atom that emits an alpha particle may become a daughter of a different element. So that's it for this question. Let's go ahead and consider the next question. So the next question we have here is question number 8. It says the nucleon number of an atom is the total number of A, electrons and neutrons, B, neutrons minus electrons, C, electrons and protons, D, protons and neutrons. So guys, the answer to this question is option A here, electrons and neutrons. So let's go ahead and consider the next question. So the next question here is question number 9. It says nuclear fission is preferred to nuclear fusion in the generation of energy because A, energy obtained from fusion is relatively smaller. B, the raw material for fusion are not easily obtained. C, the byproducts of fusion are very dangerous. D, very high temperature are required for fusion. So guys, option D is the answer to this question. Very high temperature are required for fusion. And that's it for this question. Let's go ahead and consider the next question, guys. So guys, here the next and last question we have here, question number 10, says, in a controlled thermal fission reactor, the use of control rods will not affect the A, amount of radiations produced in the nuclear reactor, B, energy generated in the nuclear reactor, C, speed of the neutrons released on fission, and D, rate of production of the neutrons. So guys, the answer to this question is option C here, speed of the neutrons released on fission. And that's it for this question, guys, and this is where we'll end this video for today. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question in the comment section below and we'll ensure to give you a response. So finally guys, we want to encourage you to join our YouTube channel community. So you can join this channel community by hitting the join button below and we'll see you right there. Thank you once again for watching this video and see you on the next one.